scientists, so we are on our second day of learning about physical changes. So you should have this sheet in front of you. And if you don't, please press pause to get the sheet and number the pages and press play to begin on the notes. All right, so the first thing that we need is our essential question, which is going to say, how are physical and chemical changes similar, because they do share one thing, yet different. So we are comparing and contrasting. We learned yesterday all about physical changes. You took notes on them. It should be in your notebook. It looks a lot like this. You may want to reference this sheet because the very first thing says physical changes blank change the matter of the object. They either do or they do not change the matter of the object. Press pause, figure it out as a class, press play to begin again. Okay, so if I looked at my notes yesterday, I saw that a physical change changes what the matter looks like, but the matter stays the same. So this is going to say physical changes do not change the matter of the object. The matter itself stays the same, even though it looks different. So I see some examples here. I see example, type, and explanation. We're going to do one together. Then I'm going to have you talk and brainstorm some at a table, make a class list, and then we'll come back and see how you did. So again, I'm going to reference these notes from yesterday. And I see that I could change its shape, I could change its state, or I could make something dissolve and do solubility. However, it's going to look different, not be different. So I'm going to do one example with us. I'm going to take this Post-it, because it's easier to see than the paper I had yesterday. I'm going to rip it, then I'm going to fold it, then I'm going to crumple it, then I'm going to do this to it. And it definitely looks different than a normal piece of Post-it. Piece of Post-it? Sure. But even though it looks different, still the same matter. This is still paper with some sticky stuff on the back, just like it was when it was in its square form. So my example is going to be ripping a Post-it. I need to know what type is that. Is that a shape change? Did I just change its shape? Did I make a solid go to a liquid go to a gas, or the other way? Or did I do solubility where I dissolved something? Press pause and figure out what type it was and press play to begin. All right, I hope that you guys came up with shape change. All I did was I changed its shape. And I want to know the explanation. And right now I'm going to say the shape is different, but matter is the same. I have the same kind of matter that I started with. Even if I were to do less, and I have less matter than what I start with, when we say the matter stays the same, we mean it's the same kind of matter. It's not new type of matter. So I could have more, I could have less. That's not what we're talking about here. We're talking about how when I change its shape, the type of matter is still the same. So you have 3 left. You need to have one example of each other, or one example of all 3 types for yourself. So we're going to repeat the fact that you as a class/table need to come up with a shape change. You as a table or class need to come up with an example of a state change. And you need to come up with an example of solubility. When you say why, tell me what this actually means, but then also tell me about the type of matter with our end result. Again, I would really recommend you reference these notes from yesterday. Press pause, do this as a table, then as a class, and then press play. Have fun. All right, so you should have this table filled in. So for shape change, maybe you ripped, maybe you tore, maybe you crumpled, maybe you cut. You have a lot of things you could do that. And over here, it's going to look just the same as this, right? The shape is new, but the matter is the same. For state change, I'll write in a different color only so that you can see it better when I write over here. For state change, did you make something freeze? Did you think about something melting? Did you think about something evaporating? What did you think? Popsicles, ice cream, ice water, steam, all those kinds of really good things, right? And for the state change explanation, I want you to say, and hopefully you did this, that it went from a blank to a blank. I'll tell you what I want there in a minute. But the matter is the same. On these two blanks, I want you to tell me what states. So yesterday, I talked about ice melting. So then I would say it went from a solid to a liquid, but the matter stayed the same. If you talked about making ice cream, that's an option you could put here. It went from a liquid to a solid, but the matter stayed the same. If you boiled and evaporated water, it went from a liquid to a gas, but the matter is the same. So these two blanks, when you are explaining state change, you need to tell me which state did it start in, solid, liquid, or gas, and which state did it end in, solid, liquid, or gas. All right, for solubility, this is when yesterday I dissolved Kool-Aid. So maybe you have Kool-Aid, maybe you have lemonade, maybe you're making Gatorade out of those packets, maybe you're making sugar water or gross salt water, okay? And over here, I need you to say the word dissolved for sure. So you're going to say something dissolved in something, but the matter is the same. So with my Kool-Aid example, I would say Kool-Aid dissolved in water, but the matter is the same. Sugar dissolved in water, but the matter is the same. Salt dissolved in water, but the matter is the same. So this one right here is your powder. This is your liquid. Usually it's going to be water for us, but the matter is the same. If you need to fix any of your explanations, I would like you to take some time and pause this video, erase, and fix. Because how you explain is really important to make sure you have all those details. So if you need to do that, press pause and then play to move on. Okay, so this was all a review of yesterday, that physical changes do not change the matter itself. But our essential question now talks about something called a chemical change. So if they're different, I wonder if you can start to infer what a chemical change must be. Think about it. Physical changes do not change the matter, which means chemical changes must actually change the matter. So we're going to say they do change the matter. It's going to look different, yes, hint, hint, that's what they have in common. But now in a chemical change, I actually get new stuff. So I have 3 different ideas for you. We're going to kind of do a couple of them together just because this is a new idea. So first off, if I take this crumpled up piece of paper, because it's notes that I started for this video and then I didn't like how I was doing them, I need to take paper plus fire, and I'm going to create a new substance. I want you to pause. I'm actually going to create a couple new substances. I want you to pause the video and think about what is she going to create when I have an unlit match and I have paper. Yes, fire, but that's not a new substance. That's just heat. So don't tell me fire. What new substance is going to happen in this paper? Press pause to do this and brainstorm. Press play to begin again. All right, here we go. I have fire. I am going to start this paper on fire. And I can see already that I'm getting some things I didn't have before. And hold on a second. So I put it out, because we also don't need to set the fire alarms off. But right now, I have this line of black ash. Ash is a new substance. I take my fire, I take my paper. I don't have ash to begin with. So ash is something that is new for me. It is new matter. Yes, my paper is still there, but I have created something new. So if I light a piece of paper on fire, then I'm going to say the new matter, because it's new stuff, is ash, and, now you can't tell this on a video, but if I were doing this live with you and you had closed your eyes, you would know that something was on fire. One of your other senses would tell you that. And I'm hoping right now you're thinking, I hope you're not shouting, but I hope you're thinking you would be able to smell the smoke. Because smoke is a gas, and it is a new type of matter. I didn't have that smoky smell, that smoky gas from plain paper. I didn't get it until I lit this on fire. So lighting things on fire is an example of a chemical change because I am creating new matter. Another example of a chemical change is when you put Alka-Seltzer in water. And Alka-Seltzer is a type of medicine. It's a white tablet. You put it in water. And when this happens, you get bubbles. And the new matter is bubbles. Because a white tablet is a powder solid. Water is a liquid. I don't have a gas. I'm not heating. I am putting them together and it's letting off this new bubbles. Bubbles and fizzing. Maybe fizzing is a better way of saying that. That fizz is my new matter. I'm going to do one more because there's a third one. If I take metal, like a car, and I leave it out, so I'm adding air to it, what happens to a really old car? You can tell what happens to a really old car. I hope right now you're saying the new matter is rust. Rust is a new thing. I don't buy a brand spanking new car and get rust. That doesn't happen. Rust is a new thing. So my new matter is smoke, ash, this fizzing. My new matter is rust, and also if something turns a color that wasn't there before. All right, scientists, we have to do our summary, but I'm running out of time on this video length because I have the free version. So I'm going to have to stop the video. You'll have to start the next video to get our summary.